Hi everyone, welcome to this talk on Kuber.jl. Um, Kuber.jl is a package that is OpenAPI based, and it's a Kubernetes client. Um, my name is Nishanth. I work on Julia Hub. Um, um, as an introduction, so I write cloud-based software at Julia Hub. So working extensively with AWS, and we write software for deploying distributed workloads on Kubernetes and AWS. And so far, our code has been written in Julia. Um, so in this talk, I'll just go over the Kuber.jl package and its basic design and usage. And we will see how we can deploy a Julia-based web server and how we can scale it from Julia. And we'll also talk about a little bit of some advanced operations. Um, okay, I just want to give a brief overview on Kubernetes so that we have some context for the rest of the talk. So Kubernetes is a open source system which was originally developed by Google. Now it's maintained by the open source community. And what it does is it orchestrates containers on multiple machines on the cloud. And as such, it makes the job of deploying containers, starting up instances, all of that easy because it's all automatic. And it's mostly written in Golang. Uh, it's also popularly referred to as K8s, so you might see that a lot. And it's happens to be one of the most widely used software systems in the world. Um, this is an architecture diagram of Kubernetes that's taken from the Kubernetes documentation. So the heart of Kubernetes is the API server here, which does which is the central point for most of the communication. Much of what we run as Julia containers, they run in the on the nodes, and the nodes have two components. They have a thing called kubelet, which is a daemon process, um, which is responsible for actually orchestrating the containers within that node, and it talks to the API server to get details on what it needs to run. There's also something called a kube proxy, which manages networking. So if you deploy something on this node and you want to access it from outside, it's the proxy which does the work for that. And there are a few other components. So what you see on the top is there's a controller manager, the CM, um, which looks into these jobs, and as their state changes, it does work to get them ready. Like if you launch a container um, to do things like bring up the container on that node and basically bring that system to the desired state. Then there's the cloud controller manager, which talks to the actual cloud. So if you're running this locally, then it doesn't do anything. But if you're running this on AWS, then that is responsible for bringing up your machines. Um, okay, moving on from this. So I just put up an example YAML file. Much of what you submit to Kubernetes is written in YAML as a standard. And whatever client you use takes that YAML, makes it an API request, sends it to Kubernetes, and then Kubernetes deals with it. So this is just a simple Julia application. So you mentioned the Docker image of Julia here. You have a command which just adds a package and runs a method in that package. And optionally, you can have some data, some external data. So for example, here there's a Git repo. Uh, but you can use things like NFS or S3. And there are a few other options. We'll see them later. But this is a basic structure for context. Okay. So why did we write a Julia package if we can just submit YAMLs and be done with it? So YAMLs are static; they're just text files, and you can submit them if that's what you wish. But with Julia, you can do a bit more. So you could write your own client for starters, as in a command line client or a web client. So typically, people use a thing called kubectl as a command line client, and there's things like the Kubernetes dashboard. If you're just getting started and you just want to experiment with this, you could maybe write your own client like this. Slightly more advanced, you could write a distributed CI service, which is quite useful. And in fact, we had one of those running the pre-Julia 1.0 days. So basically, you could write using GitHub.jl, you could write a GitHub webhook listener, and then based on what packages are getting registered, you could start jobs on your Kubernetes cluster. So the practical use of that was that we wanted to test reverse dependencies of a package. So if a package has a lot of dependencies and somebody registers a new version, we want to make sure it doesn't break like a bunch of packages. So that was one place where we used this. Apart from that, you could write a web application for your company or your organization to submit jobs, because not everyone's familiar with Kubernetes. They wouldn't submit YAMLs, right? And maybe slightly more advanced, you could write your own autoscaler or some kind of automatic manager, as an example. So Kuber.jl gives you the tools in order to write that. So we'll talk a bit more about the API which makes that possible. Just a small note on my dev setup. So I'm just running OpenSUSE Linux on this laptop, and I have K3s on it. There's the link for K3s in case you're interested. K3s is a lightweight Kubernetes, which is great for learning and testing on a single instance on like your laptop. Yeah, and my K3s is configured to use Docker, so you can build Docker images locally on your laptop and make use of it in your cluster. Okay. Brief intro on Kuber.jl. So this is based on OpenAPI. So much of the code here is generated from a specification file, and we have some wrappers around it to make it easier to use. There's a link for that. It's open source, so you can install it with the --add command. And the API is fairly low level in the sense, not close to the metal, but low level in the sense we expose the API as is, and you might find that you might want to write wrappers to do some common tasks which you might have. But it's pretty powerful in the sense that the API is pretty close to the spec that's provided. So the package functions are modeled on this idea of verbs and nouns. So nouns are just the entities that you have on Kubernetes. So typically you might use something like a job to run some Julia code to completion. Ultimately, everything becomes a pod. It's like the basic unit of Kubernetes, and the pod contains the container that runs your code. And there are higher level ways of, I guess, mentioning what you want to run. Like there's a deployment. which is what you would use for things like web services. You can scale deployments in a certain way. And apart from jobs, there are things like networking. So there's a object called service, which can use for load balancing. And then there's namespaces for isolating the various resources. So all of these nouns can be passed to methods, which are defined in terms of verbs. So you could get details about it, you can update, you can delete, and you can watch those changes to those entities. And we have some helper methods. So for example, we have setNS, which can be used to change the namespace of your current context. And we have setretries, which we use in production because you want to make it more robust in production. So this is just like the basic code, basic hello world example, I guess. So you just say using Kuber, you build the context with Kuber context, and you set the server here, and you pass the server endpoint. And over here, I'm just running a get method on pods, and I mentioned namespace as nothing, so it selects all namespaces. So I haven't shown the output there. It's fairly large. The output renders as JSON, but it's not JSON. It's actual Julia structs, which we've generated from the OpenAPI spec. And that's useful because you can then index it and get the specific field that you want, and filter it, and we'll see an example of that later. So just want to talk about a brief example of deploying Julia web server. So I'm going to start with what's called a config map. So any application that you deploy has some config. So I have a sample application here. So I'm using Postgres database. So I have some Postgres credentials here, like the password, the user, the host. And a config map is an entity in Kubernetes. So using Kuber.jl, I can submit a config map using the put bang command. I have to pass the symbol config map as a second argument there. And in this case, I'm using YAML. So I'm using the YAML package, but what it requires is a dictionary ultimately. So you could just use a dictionary. The second piece of a web server is the actual deployment itself. So this is a deployment. And I've just highlighted some important parts of this. So you can mention the number of replicas. So that's the number of containers you want. It's just set to 1 for now. There's a port 8080. And then there is the Postgres secret we just created. We just mount it as environment variables here. So once again, it's the same API. It's just put with exclamation, but you have to mention that it's a deployment there. And moving on. And the final piece is the load balancer to expose this API outside of Kubernetes. So here we just say, take the port 8080 of your container and map it to port 80, which is a standard HTTP port. And once again, the same API, but you mention service. And when you do that much, you get your web application running. This is just a sample web application that I've written. And here's just the local IP that it generates. If you're running this on AWS, you will get something different here. Like you might get the load balancer actual name, and you might use it in your DNS service and get a nicer name from that. Yeah. Okay, so that was about deploying a web server. Now, what if you wanted to scale it out? You had one container, you want multiple containers. You can use the update method, And to update method, you just say you want to update a deployment, the name of the deployment, and then you need to specify that you want 2 replicas. So when I said the API is low level, I meant this. So ultimately in your code, maybe you want just a one-liner, so you can wrap around this. But right now, basically, it's like this. So once I scale it to 2 containers and I list the pods, I get 2 of my demo apps instead of 1. So now the app is scaled to 2. Similarly, you can scale it back down. You can change that to 1. You can even change that to 0. It's going to just sleep in that case. There's not going to be any apps. And then you can change it back to 1 when you need it. And finally, we have the delete API, with which you can delete the resources. So delete API can be used for, in this case, it's just used for deployment, but you can delete the other resources as well, the load balancer and the config map. Okay, so that was about web server. Let me just briefly talk about using Julia's distributed standard library for doing distributed tasks. So what I'm going to show is having a master container connect to some worker containers, and to communicate, we are going to use clustermanagers.jl, which is an open source package. So this is actual code. Some of the code is hidden in this common file, but most of it is here. So on the left side, you have the master's code. Right is the worker's code. So you just say using cluster managers, and we have this cluster manager, elastic manager method or constructor, which starts up a server on the master for the workers to connect to, and it happens asynchronously, so it's going to come here. And we have this while loop here, which just waits for n workers to come to, so we want 3 workers here, so we wait till we have 3 workers, and we sleep for 5 seconds while we do that. So on the worker side, we just have the elastic worker method being called, and as the workers connect, n workers is going to get incremented, and at some point it's going to be equal to 3, and that's when we come out of the loop. And inside this estimate pi method, I have a pmap, and you can use all your distributed macros there as well, like at everywhere, spawn at, and that's going to make the workers, that's going to send out the command to the workers to start working and return the result. So yeah, that's how you would use distributed package. Oh, sorry. Okay, thanks. Okay, I'll just go through. So this is a corresponding YAML file for the master. I'll just quickly go through this. This is just a master node with the same port being exposed, and we need to have a service as well for that port for the workers to connect to. And this is the worker specification. So for worker, we just mentioned the number of workers as parallelism here, and we want to limit it to 1 CPU. So we mentioned the request here. Okay, so the output looks like this. It's going to wait for some workers for some time, then finally it's going to get the value of pi there. And if you list the containers, you're going to see 1 master and 3 workers. I just put this slide here just to mention that you don't have to use distributed. You could use something like ZMQ. There's more details on the ZMQ website. Okay, just a brief note on GPU. What do you have to do to run GPU jobs on Kubernetes? Well, first of all, you should have GPU hardware. On your container images, you need to have CUDA installed, Kuber.jl. You need to have NVIDIA drivers, if it's an NVIDIA GPU, installed on your node. And you need to specify nvidia.com/GPU1 or any number that you want in your specification of the job or the deployment. You also need this NVIDIA plugin that's freely available on GitHub, installed on your cluster. And finally, some environment variables that needs to be set. So I had to just go through this to make GPU work, so I thought I'll just mention this in case it's useful for anybody else. So coming to the watch API, so we have an asynchronous API, which lets you watch resources and get updates and then take action on those updates. So why is asynchronous good? Because if you want to watch some resource and you keep calling the API server, that's just expensive. Watch is just one method that you call, and then you keep getting a stream to your closure, and then you can do whatever work you want here. So where is this useful? So it's useful if you want to write your own monitor. Let's say you have some instances in your office and people in your office are using this cluster, and you want to keep an eye on what's happening. So you could write a watch on, say, the node resource instead of pod, and you could get a list of changes happening to the nodes in your cluster. And similarly, within the closure, you can use the write APIs, such as put or update, to make changes to the nodes if you wish. Okay, do I have time? Okay. Oh, okay. So as I said, Kuber.jl is based on OpenAPI.jl. So 2 days ago, we had a talk from Tanmay about generating a client using OpenAPI. So Kuber.jl is such a package which uses OpenAPI. So if you ever need to use custom resources, you can generate the API, and it's fairly easy to use it with Kuber without having to modify Kuber. You can keep your API module in a separate package, and in the Kuber context method, you can just specify that package as API module, and that gets plugged in and it gets used. It's easy to use that way. All right, so just go through the summary of what we talked about. So we just presented Kuber.jl, which is based on OpenAPI. Went through the basics of deploying a web application. We discussed distributed Julia as well as GPU workloads. And we talked about the watch API, which lets you get change notifications. And we talked a little bit about the internal details. Yeah, so in conclusion, having a Julia programming interface to Kubernetes is great because you now have one language for your data analytics, your web programming, as well as Kubernetes programming. So if somebody wants to get into Kubernetes programming and they are familiar with Julia as a machine learning or data analytics language, they can now start using Julia for Kubernetes. Thank you. Thank you for this.
So, any questions? Yeah, one more already.
Hi, thanks for the talk. I had 2 questions. One was, do you use the .cube config file at all to pick up configuration settings?
No. We have our, I mean, we don't look at configuration in this case. So if I have to show an example. So here's an example of something that connects, that actually works. So we just use a token which is a Kubernetes secret, which is linked to a service account, which has access to the cluster, and that's it. That just gives us access to the cluster. Yeah.
Okay. My other question was about errors from the API. What do they look like? Are they just raw JSON, or are there special like Julia types?
It depends on the error. So it would be, I think we use downloads.jl, I think. So you would, if you get a 503 error, then it would be like a downloads.jl error. Yeah.
Okay. There's no custom Kubernetes errors.
No.
Okay. Gotcha.
Any other question? No. Thanks for the talk.
Thank you.